Hey everyone, welcome to Graph Time with Sara and Sean. I'm Sara.
And I'm Sean. Sarah and I make animations, games, and art using math.
Today we're really excited to explore surfaces in the 3D graphing calculator, and we're going to add some cool colors on top of them to see what we can make. All right, so here we have our 3D graphing calculator. And Sean, I am going to need some help just graphing stuff, but we can graph surfaces in 3D. So here's my surface z equals 2. And I might want to make this more exciting. And I don't know so much about graphing in 3D, but I'm just going to try things and I will learn as I go.
We're going to model productive struggle for you.
Yeah. Okay, it looks like a sine wave, but in 3 dimensions. Okay.
Oh, there you go.
We're starting to get somewhere. And I might just keep it like this just for starters. A cool thing that we could do is we can actually pick a color for each point on this surface and based on where it is in the 3D space. We love colors. I love HSV color space. So it might be fun for us to pick a different hue based on like the X, the Y, and the Z value. We might just start by only using the Z to make the color. Maybe like the higher or like the greater the Z value, like or greater distance from 0, we want it to be like more red or something like that.
Yeah, so the Z is like the height. And so what we're going to try to do is as you go up in height, we change to a different color value.
What I think like the simplest thing I could do is just make it Z.
Yeah, this is like the best way to go. Yeah, now
didn't do anything.
Well, yeah, you got to select it, but it's still not going to do much. I think because one, the color values go to for HSV is like 360, and these are only going to 5, so they're probably all going to
red. So my
also
math
that gets negative too, which I'm not sure what that even means. It probably just like wraps or gets capped or something.
Oh, whoa.
Oh,
that looks like the storybook with the like.
Yeah, well, that definitely okay. Yeah, so now like the color of this is based on the height, so you can look at like every height.
Yes.
Is the same color like at that fixed height.
Yeah, and I might even want to try like I'm curious what this would look like on like a linear.
Oh, yeah, okay.
Like exactly what's going on. And when we make a different surface, it's like intersecting the colors or something. It's how I'm thinking about what's happening. At this height, everything is going to be turquoise.
Yeah, that makes sense. What is happening when it's getting negative? It's just kind of looping around, it looks like.
Oh, yeah. So maybe I actually want the absolute value of Z. I don't know if that's going to change anything. It did. It's like, I don't know what negative hues do, but this is now like a little more symmetric.
Yeah, you could like add 5 to the Z.
Yeah.
Just so that everything because I'm just said 5 because we're going from -5 to 5 on the graph here.
Yeah.
And then maybe divided by 10 instead of 5, which I think will make it just be like one rainbow.
Maybe? Oh,
well, there's no red because we're not actually going to 5.
Oh, yeah. We're going to 2. No, we're going to 3.
Yeah, okay. Yeah.
Okay, so I can go like this and see it from above, which is pretty okay.
Nice.
This is pretty cool.
I like this view. Like I like just looking at it from the top.
Yeah.
Maybe I'm biased towards the 2D calculator, but
okay, let's see what happens if I add an X. What do you think is happening when I add an X? Well, maybe I need to add a way bigger number.
Yeah, exactly. Yeah, so yeah, exactly. There you go. Now it's
something's happening. How interesting.
Honestly, I feel like it'll be a little bit easier to control just for doing the Z. But
yeah,
maybe just like leave it as the Z being changed. Oh, hey.
I'm having too much fun to do that.
That's actually pretty cool.
I like this. I don't know what we've done here, but I think it's kind of fun.
Yeah.
Okay.
That's pretty cool, and I think will also just be hard to control, but
Yeah.
let's go for it.
Sean, do you want this graph?
Yeah,
Let's do it.
sure. I'll take it. All right, cool. I feel like I want to add some movement to this graph. I
Totally.
think that would make it fun. So I'm gonna go into here and make just a slider that we can move around to maybe like make this surface. I think I also want the surface to be a lot shorter than it is. So let's see. I'm going to take this and multiply it by a small number.
Oh my gosh, I already love this. That's so pretty.
Yeah, and then I feel like I want it to kind of like move around like waves. I want to turn off lighting so it's not so
Oh,
shiny.
because we're gonna make our own lighting. Sorta.
Yeah. Okay, so I want this to kind of like shift around and bubble around. So obviously, I think when in doubt, we're just going to add some more trig in here. So if I just, that's going to make the whole thing go. But I don't really want to.
Because you're adding to the Z.
Yeah.
Oh, the Z is always adding. The Z is always going to go up and down, but you don't want everything to go up and down.
Yeah, maybe I want to throw the A in here too, because this first sign is kind of like how this how the plane is bubbling. So if I put like an A in here, or maybe if I like add an A in here as I go, yeah, here we go. Now we're gonna start like waving. So that's kind of like a flag.
Yeah.
And if we do that like a little bit more in different directions, then we'll have some pretty cool effects. Although honestly, it's like
It's
let's
really
slow it down a little bit, but it's kind of fun. But it's moving like pretty diagonally, I feel like. So maybe we'll try to do something here as well, but maybe not the same amount. Maybe just like a smaller amount, maybe minus, to just kind of get some variation in here.
Yeah. Can you make your slider be on a loop, maybe?
Yeah, that's a good idea. And we also want it to have to. It would be nice if it didn't like jump.
If it was continuous.
Yeah. So if we put a 2π on these.
Oh,
Well,
then
I
just
don't know if
really
that'll
slow
work.
down the slider. I don't know, because it's actually you're shifting it, so I don't think it's going to be 2π.
Yeah, because of that. Yeah.
It'd have to be like 2π, and then in parentheses you do the shift.
Yeah, I think I could do it like this if I separate it out into a different cosine. Yeah, there we go.
Good job. I don't know why that worked.
Yeah, could I explain it? I don't I mean, there's the 2π in there. I guess here's what I'm thinking. Like these two things kind of combine together, right? So it's like mostly what it started as, but we're adding like a little bit of rippling. And that little bit of rippling is going to, since it has 2π and this is over 1, that's going to like repeat on a loop.
Mm-hmm.
Maybe I want to separate this one out as well, actually, too. Just so we have a little more control.
I kind of want a little more like up and down movement. So I feel like if you change one of the Y's to have a bigger coefficient, that would be cool.
Let's see what it looks like from the side.
Or maybe that 0.2 in front, I want to be like a 0.5 or something. I just feel like it's not breaking out into a new color as much as I want it to. Yeah.
A new color. I was thinking we might start messing with this to add some color in.
Oh.
Or actually.
Oh wait, see what happens when you change the 0.2 out front. I need to know.
Oh sure, yeah, absolutely. Sorry. Oh nice. Well, yeah. I mean that definitely. Yeah, it's definitely nice. I feel like I want to try to like. There's maybe too many colors here.
Okay.
I want to try to make it a little less going through the whole color spectrum.
Okay.
So how do we do that? I guess we just make this smaller. We want the numbers to be smaller.
Yeah.
So maybe if I divide this by 12 instead. Okay.
Oh, nice. You can change the saturation almost. It's like it could be like to be based on Z also, maybe. So it's like more saturated
Well,
in some places.
yeah. Okay. So let's go with the trig too.
Yeah,
So like the sine 2 times the sine, or actually like 0.1. So what this does is it should fluctuate the saturation from like
yeah,
0.7 to 0.9,
yes.
which, oh yeah, that adds like some more definition in it. That's cool.
Yeah. Maybe we make it between like zero. Maybe we change that 0.8 to a 0.7.
Yeah, kind of like lightened it up a bit.
Yeah.
All right, let's like, okay, so we can change what color it is by adding numbers here.
Oh,
Oh, okay. I think I want to try to get the green out of it entirely. So maybe we even need to go like, oh, that's kind of
cool.
fun.
Yeah.
But I want it to ripple more.
There's also that x plus y minus 5. There's that whole second part of
Oh,
that.
this? Yeah, what is this doing? Whoa, that's doing a lot. That's doing a lot of work. I mean,
Add
I like
a
it.
2x. Or sorry, make like the x or the y like not equal to each other. I think it'll look less linear. Just kidding. Oh,
Yeah, maybe we want to just have this have less of an effect. What's happening? Okay, so this is kind of like coming in and out.
what if you one of your like cosines you add like some nines or something to make it a little less uniform looking?
Yeah, just throw some variables in all around here.
Yeah.
Or not variables, but different numbers.
Yeah.
Oh, there we go.
That's cool.
Yeah. Yeah, there's like so many. Oh, you know what? I'm gonna try to putting this on a slider.
Oh, what if you put A into the color somewhere?
Yeah, if we put A into the color somewhere, what should happen is like as it animates, it kind of like changes color.
I think that's fun for us to try.
Kind of like that. Kind of like this actually. As I move the slider. Yeah, let me just take that out. So if we put A, so we probably want it to loop again. So we'll put it in a sign. So where would we put it? Like here, like plus
Put it
sign
Sure, yeah.
of 2 pi a, but we need it to be more because like the color number is really big. So like 50. Whoa, too much. All right, anything else we want to try? This is pretty fun.
It is really fun. What if you made a sign, you added to the surface a sign that depended on X and Y?
That's gonna just make, I think, the surface kind of like bubble differently. Like
Oh.
it's not actually the moving. It's like just kind of like stretching the whole thing. Oh, that's pretty fun
Oh,
though.
it
Look at
looks
that.
like one half is always taller, so I wonder if
Yeah, that's
that half
nice.
not as tall. I don't know where that's coming from.
Yeah. Oh, this one.
Yeah.
Yeah, that's true. I bet you're right about that. Yeah, that makes it a little more uniform.
This is cool. I really like the way this looks.
Yeah, lock it in. Are we done?
It's really pretty. I think so. I think it's great.
That's fun, and like honestly, like it didn't take us very long to mess around and have something really cool. And I feel like we could just kind of endlessly tweak this to make it different. Like if we put 100 in here, like,
Yeah, there's so
oh, that
many
was
cool things
1,000.
you could try.
Ah, I'm losing control. Okay.
Yeah, I think fun challenges is like you could try and make something that looks like a lava lamp. You could try and make things that are way less curvy than this, like maybe less organic type shapes. Maybe things that look like clouds floating around. I think there's so
Yeah.
many cool things to try, lots of challenges.
Yeah. I already want to try one of those challenges. I bet we can make it more like a lava lamp if we just like right now we're just like on a small spectrum of the colors, like the blue and the purple. So if you just did like 12 here, or wait, no, the opposite of that. There you go. That's like
Oh, okay. And then to make it happen less in your function, instead of 1 out front, make it like 0.1 or like 0.
we could also just like divide that. Oh, that's kind of fun. Yeah, there's a lot you can play around with here and make
Yeah.
really crazy changes. Cool.
All right. Thank you so much for graphing with us and watching this video. Leave some graphs in the comments if you decide to make something new and different.
See you next time.
Graph time, laugh time, math time, graph time. Let's get creative and play with some graphs. Come round the table and we'll do the math. Graph time! With Sara and Sean.